I am Dr. Shweta Sharma from ABES Engineering College, Ghaziabad. In this lecture, I'll discuss about the various contents which I will cover in the upcoming lectures of Unit 2, Spectroscopy and Stereochemistry. In Lecture 1, there will be discussion of introduction of spectroscopy, that is the study of spectrum. Following with this, there will be the UV visible spectroscopy principle. That UV visible spectroscopy is based on the principle of Beer-Lambert's law. Along with this, examples. Then continue with this, there will be the various terms which are used in UV visible spectroscopy like chromophores, auxochromes, absorption shifts, that is bathochromic shift and hypsochromic shift, which are also known as blue shift and red shift. Then there will be discussion of intensity shift, which is hyperchromic shift and hypochromic shift, along with the examples of both the shifts in UV visible spectroscopy. Then there will be discussion of the instrumentation of UV visible spectrophotometer or UV visible spectroscopy. Then applications of UV visible spectroscopy and the various questions related to the Beer-Lambert's law, in which there will be discussion how the concentration of any medium can be determined by using Beer-Lambert's law, how the constant of Beer-Lambert's law, that is absorptivity and molar absorptivity, can be calculated by using Beer-Lambert's law, and also how the absorbance and transmittance of a medium can be calculated by using the Beer-Lambert's law. Then lecture 2 will be the discussion about the IR spectroscopy. The contents of lecture 2 will be introduction of infrared spectroscopy, then the principle of infrared spectroscopy, which will cover about the Hooke's law, how the bond behaves like a tiny spring, and how we can apply the Hooke's law to the vibrating bond. Then various regions of IR spectroscopy, which will cover the discussion of 4000 centimeter inverse value to 400 centimeter inverse value in the regions of IR spectroscopy. Then there will be discussion on the fundamental vibrations of IR spectroscopy, which will cover both stretching and bending vibrations types, stretching vibrations and bending vibrations, both asymmetric and asymmetric stretching vibrations, bending vibrations, which will be in plane bending vibrations like rocking and scissoring, and out of plane bending vibrations like wagging and twisting. Then I'll discuss about the instrumentation of IR spectroscopy, applications of IR spectroscopy, and the various questions related to the IR spectroscopy. Lecture 3 will be about the NMR spectroscopy, nuclear magnetic resonance phenomena. This lecture will contain first the principle of nuclear magnetic resonance phenomena or NMR spectroscopy, then how the NMR can be studied. We are taking the example of the proton. Proton is a NMR active nuclei with a I value of 1/2. Then number of signals will be calculated in the proton NMR spectroscopy. Then there will be the discussion of the chemical shift, how chemical shift takes place in proton NMR spectroscopy with reference to the standard compound TMS. Then there will be the discussion on shielding and deshielding effect, spin-spin coupling effect, reference compound used in proton NMR spectrum, that is TMS, tetramethylsilane is used as reference compound, why it is used as a reference compound, and what is the utility of this compound. Then solvents used in the proton NMR spectroscopy. There will be the discussion on this, which includes the use of non-hydrogen containing solvent, hydrogen or proton containing solvents, or we can say that deuterated solvents are used. Then selection rule of NMR spectroscopy, instrumentation of NMR spectroscopy and the various applications of proton NMR spectroscopy. Lecture 4 will be about the stereochemistry topics, in which there will be discussion about the attrop isomerism, which is the optical activity phenomena without chirality. So, attrop isomerism is optical activity without chirality. This topic will be discussed by taking the examples of biphenyls, which show the attrop isomerism phenomena, then allenes and spiranes. Then there will be discussion of the chiral drugs with the suitable examples of thalidomide drug and the ibuprofen drug, which is used as a important drug, and how these chiral drugs are used and how their different enantiomers behave differently when they are in contact with the biological system. Then there will be geometrical isomerism, that is cis-trans nomenclature. Along with this, there will be discussion of the EZ nomenclature on the basis of the CIP rules, Kahn, Ingold, and Prelog rules. Then lecture 5 will contain the discussion on the previous year question papers or the frequently asked question papers in the university examinations. So in this way, the whole unit will be covered in the 5 lectures. These are the references which will be discussed, which will be considered for the discussion. Thank you, all of you.